Welcome back. We are finishing up our section on 2-1, relations and functions. We're going to talk about function notation. Now, in Algebra 1, we wrote a lot of our equation as y equals fx plus 2. Or here, y equals 5p squared plus 6p minus 7. We can look at this. We know this is a line. We know this is a parabola. And we know it's opening up because the 5 is positive here, our a value. However, we want to start thinking about this, writing in a little fancier way called function notation. Now, we take our function like this, and we rewrite it. And what we're going to do, we're going to place the y with the f of x equals 3x plus 2. This and this mean exactly the same thing. When we put a value in for our x, because remember our x is our domain, or our input value, we solve that, we get our range here. So if we're to use a table, and this would be read like the function of x. So let's just do 3 values. Let's pick -2, 0, and a +2. If we plug 2 in here, or -2 in here, we have 3 times -2 plus 2. We see that when we work it out is -4. When we plug 0 in here, 3 times 0 plus 2 is a +2. And if we plug 2 in here, 2 times 2 is 4, plus 2 is 6. So, our input value, if you can see, whatever goes in here has to go in here as well. So our domain, if we want to list it out, would be, we can also list it out like this, -2, 0, and +2. Our range, we can list it out as -4, 2, and 6. And that's how we would evaluate this function. Again, the input value is this value. The output value is our final answer. So if we're doing a mapping, we'd see a -2 go to -4. We'd see 0 go to 2. We would see 2 go to 6. So here, now if you notice, the variable here was x. What is the variable here? It is p. So instead of writing f of x, I'm going to use this value and write f of p equals 5p squared plus 6p minus 7. Now I know you all know how to plug numbers in, so I'm going to save you the trouble and try to go through this a little quicker. But instead of I'm going to use easier numbers, just to get an idea of maybe what this graph will look like. I'm going to use -1, 0, and 1. You can use any value you want. I'm just picking some easy ones. So if I start with -1, I would have 5 times -1 squared plus 6 times -1 minus 7. I know -1 squared is 1. 1 times 5 is 5. 5 minus 6 is -1 minus 7 is -8. I plug 0 in. I know anything times 0 is 0. So I know that part 0, that part 0, and I have -7. And if I plug 1 in, I have 5 times 1 squared plus 6 times 1 minus 7. 5 plus 6 is 11, minus 7 is 4. So I just evaluated my function. Whatever value goes in here also goes in here as well, wherever the variables are. And this is then going to be a parabola. How it's opening, we can still investigate it, but at this point, we kind of demonstrate what we're looking for. So our domain, again, -1, 0, 1. Our range is our y values, -8, -7, and 4. Last problem on your on your notes. There's a word problem. Tickets to a concert are available online for $35 each, plus a handling fee of $2.50. The total cost is a function of the number of tickets bought. What function rule models the cost of the concert tickets? So let's think about this. We want to write a function for total cost. So, since we are creating this, we can pick whatever variable we want. Since we're talking about cost, so the function of the number of tickets, so tickets sold. So I'm going to pick t as that input variable. So I'm going to write this as f of t equals. Now it says $35 each. Now whenever we hear the word each, and it's $35, so for one ticket it's $35. For two tickets it's 35 times 2. For 3 tickets it's 35 times 3. So it's multiplication. So I know this would be 3 times t. Now it also says there's a handling fee of $2.50. Whether it's 1 ticket, 4 tickets, 1,000 tickets. It's happening one time. There's our equation. Happening multiple times, we need to multiply it by a variable. If it happens one time, we're writing it as 2.5 or $2.50 for that one-time occurrence. So then we can plug numbers in, whatever you want. If we sold 100 tickets, we can evaluate that. 75 tickets, we can evaluate that, and so forth. So in this problem, we were just looking to write the equation in function notation. So, hopefully that helps. That concludes section 2.1. Remember, thinking about it, we're just switching the y value with the f of x, or f of whatever variable we're using, and it's the same thing as looking at y equals mx plus b, or something like that. All right? See you next time.